All right. So last cycle we talked about the pelagic regions, the mesopelagic and the deep sea pelagic region. This cycle we got to talk about the seafloor and what's going on the seafloor. We're going to look at 3 different habitats that you will find on the seafloor: the abyssal plain, a cold seep, and a hydrothermal vent. Okay, so cold seeps and hydrothermal vents we will watch when we complete our movie, right? And you'll see both of those types of habitats in the movie. And then you pretty much, yeah, you already saw the abyssal plain in the video. Okay, so the abyssal plain is the first one that we're going to look at, and the abyssal plain makes up most of the seafloor. So the next little bit that we talk about for things that occur on the seafloor, that's going to make up most of the bottom of the ocean. So everywhere that's in blue on that picture that you see, that is the abyssal plain. All right, so it makes up most of the seafloor. The food source for the seafloor is the same as in the deep sea pelagic and mesopelagic regions. It's whatever falls down from above. So it is mostly made up of marine snow. At this point, the marine snow is pretty much made out of mucus, copepod poop, and dead plankton. And that is the main source of food for this area of the ocean. Sounds appetizing, huh? Gross. So copepod poop, mucus, and dead plankton make up the majority of the marine snow. You also get other bigger things that fall down to the bottom. You saw this on the video as well, like the whale that fell all the way down to the seafloor. Okay, that's called large particulate organic matter. Those are going to be larger, and they're going to provide a good source of food for things that live in the deep sea as well. And then you also have bacteria as a source of food. The bacteria are going to live on the seafloor. They're going to be decomposing that marine snow and other things, and they will also be a source of food. So marine snow, large particulate organic matter, and then also bacteria. What's kind of interesting is the size of the food is actually going to determine a lot about how much of its nutritional value it retains when it comes from the surface. So if you have a small piece of food like marine snow, that's going to fall down to the bottom very slowly, right? It's going to be moving very slowly. As it moves down, because it's moving so slowly, it's going to have many more opportunities to be eaten, digested, and then pooped back out. And then it keeps going, can get eaten again, digested, and then pooped back out. Okay, and eaten again, and digested, and pooped back out. So if it's a small piece of food, okay, it has lots of opportunities to be eaten and then pooped back out. And so by the time it makes it all the way down to the seafloor, most of that nutritional value that was there is gone, okay, because it's been used up. But if you have a large piece of matter like that whale or a fish, that's going to fall much more quickly, which is going to give it like less time to get eaten and then pooped back out. So it retains most of its nutritional value once it gets to the seafloor. So the bigger the pieces of food, the more nutritional value it has for the animals that live here. Yeah? Make sense? Okay. So the animals that live here have an advantage over the mesopelagic and the deep sea pelagic animals. And that is the presence of the bottom. Okay, the presence of the bottom is pretty much the one thing that determines or differentiates this zone from the mesopelagic and the deep sea pelagic regions. So the bottom is here. And it's got pretty much the same like characteristics, physical characteristics as the areas above it. So it's going to be really cold. It's going to have a lot of pressure. It's going to be dark, but you do have the bottom. The bottom, we have not sampled much of the abyssal plain. So we've only sampled about 5,400 square feet of the abyssal plain, which is not that much. Okay, it's really, really hard to get down here because the pressure is so great. And so by the time we get down here, it takes hours to sink to these depths. By the time you get down here, they can only spend maybe 20 minutes down at the bottom before they have to start ascending again. So it's very difficult to actually sample the seafloor. And there's very few submarines that can actually make it down to these depths. We have been all the way to the bottom of the Mariana Trench, So it's 35,814 feet, which is pretty far. That's the deepest part in the Mariana Trench, called the Challenger Deep. So you've made it all the way down to the deepest parts, but still don't know much about the seafloor. So the animals that live here do have an advantage over the animals that live in the pelagic regions above. And that's because of the presence of the bottom. The presence of the bottom actually makes a big difference, because if you are in a pelagic region, let's say you're one of the sit and wait predators, you're just like sitting here floating in the water column and you wait for something to come by. What if like a piece of food falls just behind you, just out of range of your detection? That piece of food falls past you and it keeps going and it is lost to you forever. Okay? So you only get one shot at finding that piece of food. Whereas on the seafloor, the food falls, hits the seafloor, and then it stays there. So animals can move along the seafloor and then find the food that's already fallen. So they actually have an advantage because the food stays put rather than just like falling past and being gone to them forever. So the seafloor helps animals to be able to find more food. Unfortunately, most of the food that does actually make it down here to these depths is going to be inedible and indigestible to many things. So a lot of it is going to be the like chitinous remains of copepods and stuff like that. Do you remember what chitin's made out of? Calcium carbonate, and then also it's a sugar. Okay. Oh, sorry, I didn't hear you. Calcium carbonate and a sugar. Okay, and so that's like the exoskeleton of arthropods. Yeah. Most things can't digest that. Luckily, bacteria can. So bacteria actually take and break down those chitinous remains and things that other things can't eat, and get the energy from that sugar, and then those bacteria get eaten by bigger things, which then get eaten by bigger things and bigger things, and that's how that energy from the surface actually gets passed up the food chain. Yeah? Make sense? Okay. So the bacteria have to decompose it in order to let that energy be released to be passed up the food chain. The next step in the food chain are going to be these things called myofauna. Do you remember what myofauna are? Small animals. They live in between the grains of sand. So they're so small that they live in between grains of sand. So these animals live in between the grains of sand that are on the seafloor, and they're going to be the things that are going to be eating the bacteria. So the myofauna are the second step in the food chain. So bacteria break down the indigestible things, and then these myofauna eat the bacteria. And then they will get eaten by bigger things, and bigger things, and the energy will get passed up the food chain. This is just to give you a reminder of what the seafloor looks like. Okay, so this is what the abyssal plain would look like. It's covered in this sediment. And so you'd have the little myofauna living in between the grains of sediment down here on the bottom. And then the myofauna get eaten by deposit feeders, things that are going to eat things that are sitting on the bottom. Polychaete worms are going to be the most abundant type of macrofauna, or big animal, that's found down here on the seafloor. But you're also going to have things like crustaceans, clams, bivalve mollusks, sea cucumbers, sea stars, brittle stars, lots of echinoderms. All right, so deposit feeders are going to dominate on the seafloor. And then you do get a few types of predators that will be found in the deep sea. They're going to be things like sea stars, squid, fish. You saw the tripod fish in the video. We also see this kind of strange thing happen on the seafloor. We see this thing called deep sea gigantism. So what happens is, like, animals that are normally small tend to be really large on the seafloor. So like an isopod, an isopod would be like a roly-poly. So on land, like, that's pretty small, yeah? In the deep sea, on the seafloor, we pull out isopods that are like this big, okay? Like the size of a small child, okay? So like they are huge. Okay, it's called deep sea gigantism. It's crazy. We don't know why this occurs, but we've got a couple theories. We think that because it's so cold down here and the pressure is so great that the temperature and the pressure actually slow down their life processes and cause these animals to live for a lot longer. So like they found clams that are 100 years old and maybe fish that are even older than that. And so because they live for so much longer, they grow throughout their lifetime and they grow to be very large. So slow down their life processes, they live for a long time, they grow to be really large, and then we also think that maybe they might need to have enough, like live this long in order to be able to store up enough energy to reproduce. Because when they reproduce, they're going to have to produce eggs that have enough yolk in them in order to sustain that baby up until the point where it's able to get its own food. Because there's no way that these animals are going to be able to like migrate up to the surface to feed and then come back down to these depths. So the little babies have to have enough yolk in order to make them grow to be large enough to survive on their own. So that takes a lot of time and a lot of energy for the parents to store up that energy to allow for them to reproduce. So we think they live this long and get this large in order to have enough energy to reproduce. So here's a couple pictures for you. So here you can see on the bottom, that's the isopod. Yeah, that's like the giant roly-poly. Gross, huh? You can see it's like the person's holding it like a child. It's crazy. This is a sea spider. Okay, that's a sea spider. So you can see like the size compared to a rock. Okay, that rock is probably like this big. So it's a large sea spider. And then here's the tripod fish, which you saw in the video.
What's that fish?
The tripod fish. Because it's got 3 things that come off of its fins, and it sits there and waits for stuff to swim by so it can eat. Okay. You do get sometimes you do get like large pieces of food that will fall down, like the whales and stuff like that. Those are called bait falls because they act as bait to get a lot of different animals to come to one area. And there is like a succession or an order in which animals show up. So we typically find amphipods first, and then they're followed by fish. So like you saw in the video, all of the hagfish and stuff that then come and start eating on that big whale carcass. So they find that food by smell. So they're able to smell the dead animal in the water and follow that chemical trail to the prey. This picture is just to kind of help you see and compare the different types of fish depending on their region. So you've got the epipelagic zone, mesopelagic, migrators and non-migrators, deep pelagic, and then the deep sea bottom, and compared in terms of size, shape, musculature, eyes, coloration, and their bioluminescence. So you can see the difference there.